Hello students, today we'll learn one of the very important concept about the practicals as laboratories are closed. So in this period, virtual lab concept is very important and have getting more attention and importance to study the laboratory, chemistry laboratory by use of the boards. That is the why virtual mode. Today we'll learn one of the experiment that is gravimetric analysis by virtual lab technique. So today we'll learn the estimation of Fe iron Fe2 plus to convert to Fe3 plus from to form Fe2O3 as Fe2O3 that is analyzed from the samples. So you know that variety of the samples like soil sample, fertilizer sample, the alloy sample or any industrial water sample may contain Fe iron in the form of Fe2 plus. So we have to convert that to Fe3 plus by oxidation and we have to get the residue of that oxide as Fe2O3 and you have to analyze by gravimetry method. So what is gravimetric method? It is the quantitative analysis method by weighing technique. So first the sample analyte that is metal from solution has to be converted into residue oxide Fe2O3. So for that 250 ml sample stock solution is required in which Fe2 plus is present. From that by pipette we have to pipette out 2 pipette of 25 ml that is 50 ml sample solution that to be placed in the beaker and then glass rod is added for stirring and continuous precipitation reaction. On burner that solution is heated and after heating nitric acid is added to convert that Fe2 plus to Fe3 plus to oxidation till yellow color. This solution is heated 50 ml solution with some amount of water, distilled water, and by addition of 2-3 ml of nitric acid HNO3 Fe2 plus get converted to Fe3 plus. When the solution becomes yellowish, in that NH4Cl powder is added, ammonium chloride, because for the common ion effect in the precipitation. Common ion NH4 plus that is present in the NH4Cl and NH4OH. NH4OH is the precipitating agent for Fe2 plus and Fe3 plus. When that is added in the hot solution of these Fe3 plus yellow colored solution added with NH4Cl, we have to stir that solution. Fe3 plus is added with the thrice OH minus from ammonia NH3 and that FeOH3 residue precipitate in the form of aqueous form, that is FeOH3 hydroxide precipitate, red color precipitate is formed in the beaker. The process or step of this gravimetric experiment analysis experiment is precipitation step. Then what happens in the next step? Next step is that is the filtration step. We have to filter that precipitate from the solution, filtration. So what is done? On a funnel, glass funnel attached to a support, we have to collect the solutions in the beaker or flask. The beaker containing precipitate, that is FeOH3 precipitate, is added on the funnel containing the Waterman filter paper. On the glass rod, step by step solutions are added to the funnel. The Waterman filter paper number 41 is used because FeOH3 precipitate is a gelatinous precipitate. For that Waterman number 41 paper is used. It is a round colored paper. It is folded to the funnel shape on which the precipitate is separated. Filtrate is collected and detected with the AgNO3 for the presence of chloride ions. If sulfate ions are present as impurity ions, that occurs in the co-precipitation process in the precipitation step. So that is removed by washing this solution with hot water, and washings are also collected. Then this funnel containing the paper, Wattman paper and residue of FeOH3 that are heated over the air cone or a drying cone placed on a wire gauze and burner for some time, that is heated. The moisture is removed and this paper containing residue on the funnel is separated from the water moisture and that from which the paper is removed by folding with the residue. A pin is attached, and the next step is performed, that is the ignition step, means burning of the paper with the residue. That is performed by inclined burner, heating and burning the paper with residue attached with a pin and pair of tongue that is holded in the hand. That paper with the residue is burnt in the previously weighed silica crucible. SiO2 crucible is used. It is weighed first, having weight W1, and in that crucible on the clay pipe triangle or a support, the paper with the residue is burnt continuously. Ashless paper is there, so ash is collected in the crucible with the residue. Paper get burnt and fumes goes out. After this ignition step, what happens? In the previously weighed crucible, the silica crucible, we get the residue and it is freed from paper ash after heating for long time, about 45 minutes on burner that is heated on the clay pipe containing tripod stand, or that crucible get heated, we have to heat that in the furnace, a furnace, digital furnace with the temperature controller is used, on in which the crucible is heated with the residue. By both methods, what we get, ashless paper, ash is removed, fumes are removed, and we get the residue in the crucible. Residue of Fe2O3. FeOH3 is converted into Fe2O3 by removal of water molecules. Carbon dioxide also removed, and then that crucible with residue is cooled in a desiccator. Desiccator is used to hold the crucibles, and it is a glass jar in which airtight arrangement is there. Moisture can be prevented from the residues. From that crucible with the residue is weighed on the digital balance. How to use the digital balance for that? On a balance, that residue with the crucible is weighed. That weight is now W2. So we have to take the difference of the weight. After weighing process, this weighing process, W2 minus W1 gives the weight of the residue Fe2O3. Crucible weight is neglected, and we get the weight of residue Fe2O3. And from that weight, W weight, that will be W gram. That weight comes out to be in 3-digit form, point not something, that 0.290 to 80 grams. That type of the W weight is obtained for the Fe2O3 residue, and there is a relation that 1 mole of Fe2 plus or Fe3 plus that converted contain 1 mole of Fe2O3, that corresponds to 1 mole of a given form of Fe2 plus in the sample. So using that relation, we can determine the amount of Fe2O3 in the given solution. We have determined that from the 50 ml, that can be converted to 25 ml, or that can be related to about 250 ml sample solution. And whatever amount of Fe2O3 or amount of Fe2 plus present in the sample solution, 250 ml sample solution, that can be determined by weighing of the Fe2O3. We can get the weight of grams per liter amount of Fe2 plus or Fe3 plus in given sample, in which iron can be determined gravimetrically by weighing technique. And this gravimetric technique is weighing technique of estimation of metal ions, especially like Fe2 plus or Fe3 plus in the form of Fe2O3 residue forms, oxide, hydroxide residue converted to oxide residues after trying ignition, and finally by weighing we can relate weight of Fe2O3 in terms of weight of Fe2 plus or Fe3 plus. So this gravimetric technique is very important, used in the pharmaceutical labs, soil sample analysis labs, or where the fertilizer are analyzed at that sample labs. Gravimetric technique is used for estimation of metal. So this is one of the estimation of Fe2O3. So what type of questions are asked? What is the gravimetric analysis? What are the steps of gravimetry that can be asked? That is precipitation, ignition, drying. Which types of the instruments, apparatus are used for gravimetric estimations that can be asked. Then the type of the precipitate of the metal is asked. Here FeOH3 precipitate have the type of gelatinous. So which type of the crucibles are used? SiO2 silica crucibles are used for such precipitates to convert into the residue form. Then what type of the papers are used? Wattman number 41, 40, 42 type papers are there. For gelatinous precipitate, Wattman number 41 paper is used. So here what is the precipitating agent used here? That is the ammonia in the presence of an ammonium chloride containing common ion NH4 plus, which facilitates the degree of separation of weak electrolyte ammonia in presence of strong electrolyte to release higher number of OH minus ions to bind with the Fe3 plus to form FeOH3 precipitate. So that type of the theoretical questions will be asked on this experiment. So this is a very important experiment for gravimetric estimation of the metals. So this type of the virtual labs we have to study for a variety of the experiments.